How can we separate a mixture of two miscible liquids? We will first see what is the definition of miscible liquids. What are miscible liquids? Miscible liquids are liquids when mixed they form a single homogeneous mixture. So again I repeat, homogeneous miscible liquids are liquids when mixed form a homogeneous single layer. Here is an example of miscible and immiscible liquids. This is a miscible liquid where two substances would have been mixed up and they form a single layer. Could be like water and acetone, water and vinegar. This is immiscible liquids, wherein the liquids are mixed but they do not form a single layer. They form these separate layers because they have different densities. We have already seen this immiscible liquids are separated by using the separating funnel. They have different densities, they form different layers, and they are separated from one another by using the separating funnel. Today we will learn how to separate these miscible liquids. Now miscible liquids are separated by a method called distillation. And we use this method of distillation because in this miscible liquids the two components have different boiling points. We use this difference in their boiling point to separate them. Like in the case of sublimation, we use a property that one substance sublimed while the other did not. In evaporation, we use the property of one component was volatile, it evaporated while the other did not. In distillation, we use the property of different boiling points. Let us take an example of miscible liquids like acetone plus water. Now if we heat this mixture of acetone plus water, the acetone will start boiling at 56 degrees Celsius while water boils at 100 degrees Celsius. So when I heat this mixture, say the temperature will start rising. At 56 degrees Celsius, I will find that the temperature remains constant because at this point the acetone is turning into vapors. And then again after 56 degrees Celsius, again the temperature will start rising. And then when it reaches somewhere 100 degrees Celsius, again it will be constant because in this case water will change into vapor. So at this point we'll get vapors of acetone, that is at 56 degrees Celsius. After all the acetone has vaporized, then the temperature will begin to rise again. At about 100 degrees Celsius, and this is 100 degrees Celsius, the water will then become into vapor. So this property of difference in boiling point is used in distillation to separate the components. This is the apparatus used for distillation, and let's name them. Here we have the distillation flask. This is the thermometer. This is called the condenser, which is used to cool the vapors. And here we have the collecting flask. So here we have a mixture of water plus acetone that we need to separate. Water boils at 100 degrees Celsius and acetone at 56 degrees Celsius. So here we have water and acetone mixed together. Mixture of water and acetone. Now as this mixture is heated, the temperature will keep rising till it reaches somewhere 56 degrees Celsius, because at 56 degrees Celsius this acetone is now going to evaporate and the vapors are going to form. These vapors will travel up into the condenser and as they move into the condenser, they are going to get cooled down because of the water, and here the vapors are going to turn into liquid. Now once the vapors turn into liquid, they will then drop down, acetone will drop down. All this is going to happen at 56 degrees Celsius. So at 56 degrees Celsius the temperature remains constant, because here acetone is undergoing a change into a vapor state. In this condenser you have water that enters into this condenser and then it leaves from here, thus cooling the condenser and helping the condensation of the vapors. So more and more vapors will then come up at 56 degrees and will rush into this condenser to be converted into vapor, into liquid. After 56 degrees Celsius, then the temperature begins to rise again. But what has been left behind here is now only water. The acetone has moved into the collecting flask. So here we have separated water from acetone. However, to use this method there should be two precautions. Here I have written this from your textbook. It is used for the separation of the components of a mixture containing two miscible liquids that boil without decomposition. That's important. So point one is these two components should not decompose while boiling. And the second is sufficient difference in their boiling point. In fact, the difference between their boiling point should be more than 25 Kelvin. If the difference in the boiling point is very small, less than 25 Kelvin, we cannot use this method of distillation. We use something called fractional distillation. So distillation can be used only when the liquids do not decompose easily and the difference in their boiling point is more than 25 K. If the difference in the boiling point of a mixture is less than 25 K, then we use something called fractional distillation. In fractional distillation, the whole apparatus is almost the same except for this addition of this. This is called the fractionating column. And this fractionating column helps in separating the different vapors when the boiling point is less than 25 K. Different vapors when the difference between the boiling point is less than 25 Kelvin. And this fractionating column, if you see, it is made up of beads. In fact, it's just a tube that is packed up with beads. And the function of these beads is to help condensation. These beads provide a surface for the condensation of the vapors. That is the function of these beads. So fractionating column is a tube which is packed up with beads, and all these beads here, they help in condensing the vapors. Here is a picture of fractional distillation of crude oil. This is crude oil that is fractionally distilled, and crude oil is made up of many components. Like when crude oil is a mixture of many components. So when you fractionally distill, you have gasoline, naphtha, kerosene, diesel oil, fuel oil. All these vapors come out of the fractionating column at different points. The one with low boiling point will be up here, low boiling point, and the one which have got high boiling point will emerge in the lower part of the fractionating column. So fractional distillation is used for the fractional distillation of crude oil to separate crude oil into its different components. So just to summarize, we learnt a distillation, and when did we use distillation? When two components of a mixture had different boiling points. That's when we use distillation. And when did we use fractional distillation? Is when the components of the mixture, their difference in boiling point was very less. It was less than 25 K. That's when we use fractional distillation. And for that, there was an addition of this fractionating column.